Okay, y'all. So we're going to start filling out our notes for today. We're dealing with exponential growth and decay. Follow along with the notes and fill them out just like we do normally in class. And there's going to be some example problems at the end that you can complete both with me and individually. My answers will be posted in the back of the room at the solution station where they normally are. So exponential growth, the formula that you're going to put in this box is y equals a 1 plus r to the t. I'll explain more what these variables mean below. But right now, just fill in the formulas. For exponential decay, it is y equals a 1 minus r to the t. So those two formulas are very similar, just one is 1 plus r and the other one is 1 minus r. The growth factor formula is y equals a times b to the t. A is your initial value. R is your rate. T is the time. And B is the growth factor. For example, when you see the words double, triple, or half in a problem, those are going to signify your growth factor. Those are going to signify your growth factor. So you know if you see those three words or words like them in a problem, you're going to be using the growth factor formula that we wrote above, the third one down. Okay, so now we're going to start working on the example problems. I'm going to read it to you and then I'm going to start filling it out. Follow along and make sure you understand my thinking. So example 1 says, in 1971, there were 294,105 females participating in high school sports. Since then, that number has increased an average of 8.5% per year. So the first thing we have to do is identify what each of those numbers that it gave us is asking for or is representing. So 294,105 females, that's going to be your initial value. Since then, that number has increased an average of 8.5% per year. So that's going to be your rate. Now we want to fill in the formula. It says it increased, so we're going to use the exponential growth formula. So we have y equals our initial value for A. If you look at your formula above, A is the first thing we're going to put. So our initial value is 294,105. So we're going to put 294,105. Now we need 1 plus our rate. So our rate says 8.5% per year. Remember, when you have a percentage, you have to convert it to a decimal. So we're going to put 0.085. And then it says, in the formula you have time in the exponent, so you have to figure out how many years it's been. Currently it's 2018, And we are looking at sports since 1971. So we're going to subtract 1971. And I've already done it for you. That comes to 47 years. So we're going to put 47 in our exponent. That's 47, not 97, 47. There's not enough space on my screen to keep writing, so I erased it, but you keep what you have on your paper there. Now we have to solve the equation to figure out what y equals. So the first thing you're going to do is add 1 plus 0.085. If you remember PEMDAS, parentheses is always the first thing we do. So now we have 294,105 times 1.085 raised 47 years. The next thing you do after parentheses is exponent, so you're going to put in your calculator 1.085 to the 47th power, and you should get, do it in your calculator now and see if you match what I get, you should get 46.25915 and a bunch of other numbers that I did not write down on my paper. You can leave that in your calculator. You don't have to clear your calculator out, and just click times 294,105. And once you do that, you should get 13,605,048 women. Now, there is a decimal, but you can't have a portion of a person, so I always round down. For the next one, it's asking you in 2008. So the A was asking about now in 2018. This one's asking about 2008. So I'm going to do 2008 minus 1971. And that gives us 37 years. Because 2008 was 10 years ago, so we're just going to take 10 years off of what we used before. Same thing. 294,105 times 1.085, because we added 1 plus 0.085, and we're raising it to the 37th power this time. When you put 1.085 into the calculator and raise it to the 37th power, you should get 20.4597. And this 294,105 stays. All of these are y equals, by the way. And after you type that in your calculator, you click multiply the two. You should get 6,017,314 women. I'm going to have you try example 2 and 3 on your own. It doesn't have to be right now. We can go through the whole video, or if you prefer, the sub can pause the video and you can work on that. Again, my solutions are on the back bulletin board, where they always are. So example 2 and 3 you're going to do on your own, either now with the video paused or later. Okay, so now we're going to work on example 4. Example 4 says, the original price of a tractor was $45,000. The value of the tractor depreciates or decreases in value at a steady rate of 12% per year. So this question is now, instead of using growth, exponential growth, we're going to use exponential decay, because it's saying it's depreciating or decreasing in value. So again, we have to pull out the useful information. $45,000 is our initial value. That's the original price of the tractor. So that's our initial value. That's our A. Our rate is it's decreasing in value at a rate of 12% per year. So our R is going to be 12%, or 0.12. So we're going to start writing our equation. We have y equals, as always, 45,000 is what we talked about as our initial value. And when we use exponential decay, our formula says 1 minus the rate. So because we know that our rate is 12% per year, we have 45,000, 1 minus 0.12. And we don't know how much time we're using yet. That is our formula. Now if you do in your calculator 1 minus 0.12, you'll get 0.88. So you can just keep that in mind when we start moving on to B. Because B asks what the value of the tractor is in 5 years. So we write our equation, y equals the original price, which is $45,000, 0.88, because that is what 1 minus 0.12 equals, and our time is 5 years. If you put 0.88 and raise it to the 5th power, because we do exponents before we multiply, you will get, or you should get, 0.52773. You can leave that in your calculator, multiply it by 45,000, and after you multiply, you should get $23,000, $747.94. Because it's a dollar value, we're going to round to 2 decimal places because that's how we write money values. Whereas in the other examples, when we had people, we're going to round down because you can't have a portion of a person. So we're going to round down to the nearest whole number. The next 2 examples, example 5 and example 6, are the same type of problem. It's depreciation. You're going to use the exponential decay formula. So you're going to do those on your own, checking your answers at the back of the room. You can also use your seat partners to help you if you get stuck. Example 7 says, a certain strain of bacteria triples every 20 minutes. If you start with 2 bacteria, how many will you have after 2 hours? So, remember I said at the beginning, if you see those keywords double, triple, half, you know to use the growth factor formula. So, the formula we're using for this one is y equals A times B to the T. This says our bacteria triples every 20 minutes. So our growth factor is 3. We start with 2 bacteria, so our initial value is 2. And then our time, this is where it gets a little tricky. It asks us how many we'll have after 2 hours, but our original value was given in minutes. So we have to figure out how many sets of 20 minutes are in 2 hours. If you think about how many minutes there are in 2 hours, in 1 hour there's 60 minutes. So in 2 hours, you multiply 60 by 2, there's 120 minutes. And you're going to divide that by the 20-minute groupings we have. If you do that, you'll get that there's 6 sets of 20 minutes in 2 hours. So our time is going to actually be 6. Now we can just fill those into the formula. So we have y equals, a is 2, b is 3, and t is 6. At this point, you'll do 3 to the 6th power in your calculator, which is 729. You don't even have to remove that from your calculator. You multiply that by 2, and you get 1,458 bacteria as your answer. Now we have a different type of problem. This problem is asking, does the function y equals 295 times 1.35 to the t power represent exponential growth or exponential decay? And then what is the rate of growth or decay? So the hint above says to determine exponential growth or decay, you have to look at the b value. Now, if you remember from the growth factor formula, b is what's in parentheses. So here in parentheses we have 1.35. Well, if you think about it, is this bigger than 1 or less than 1? Since 1.35 is bigger than 1, it's going to be growth. If it was less than 1, it would be decay. So now that we know it's growth, we can use that information to figure out the rate of growth. In the growth formula, in parentheses, we have 1 plus r. And here in parentheses, we have 1.35. You set them equal to each other. Now you have to solve for r because we want the rate, and r represents the rate. So we're going to subtract 1, and whatever you do to the left, you have to do to the right, so we subtract 1 from both sides. Over here they cancel, and on the right, r equals 0.35. So our rate of growth is 35%, or 0.35. There's one more question kind of like this below. Again, you're going to try this one on your own. My solution is at the back of the room. Utilize your seat partner if you get stuck. You're now going to be working on a worksheet where you just practice these types of problems, and I will be grading it, so make sure you're working. Love you all, and see you on Monday. Have a great weekend.